Hi, for those who are listening to this presentation, my name is Qianwen Xu. You can call me Ariel as well. I'm a first-year PhD student, and it's good to be here to introduce our paper. The paper I present today is a systematic review of social media-based sentiment analysis, emerging trends and challenges. It is published in Decision Analytics Journal. This paper mainly explores the challenges that the scholars have encountered and other potential problems in studying sentiment analysis in social media. My presentation today has 8 parts. Firstly, I would like to introduce our research motivation. In the existing literature, a large number of scholars have worked on improving the performance of various sentiment classifiers or applying them to various domains using data from social networking platforms. However, the increasing volume of data from social network platforms, the variety of data, models, and algorithms used in these studies, and the wide range of domains involved make it difficult for interested parties to choose the most appropriate one for their research or application. Therefore, this paper aims to outline the PRISMA framework to summarize the existing studies and identify challenges and issues that scholars have faced or will face, as well as provide the potential solutions. The next part is about the systematic review protocol. The review process is divided into 5 stages, which consist of the identification of research questions, search strategy and search selection, attribute extraction for selected articles, and analysis and discussion. Our research questions are: the first is, which sentiment classifiers, datasets, and evaluation metrics are most used when studying social network media data in different domains? The second is, what are the challenges faced by authors when performing sentiment analysis on social media datasets? The third is, what are the potential issues in the existing literature on sentiment analysis of social media? The second step is search strategy. The literature search was conducted by following the PRISMA framework, which includes the identification phase, screening phase, and inclusion phase. In the identification phase, we search 2 scientific digital databases for relevant articles, the Scopus and Web of Science. The publication period was restricted to between 2018 and 2021. Such terms used to acquire articles can be classified into 3 groups: sentiment analysis or opinion mining, comment or review, and social media. In addition, the search indices were limited to metadata, for example, the title, abstract, and keywords. In the identification phase, 472 articles were identified from the 2 databases, and 76 records are duplicated. Therefore, there are 396 records were processed in the next phase. They was firstly screened by reading its title and abstract so that whether each paper met the exclusion criteria could be determined. The exclusion criteria are: the first is about social media paper. Records that concern the information distributed on independent social media platforms should be included, and that on corporate official websites or e-news should be removed. The second is about methodology. Records that employ a qualitative method or in which the sentiment analysis is not the research center, but a part must be conducted to study other research topics were included. Then the original studies, review papers, and editorials were excluded. Then is a dataset. Records that use the dataset in the form of photos, images, or audio instead of text were excluded. The last is about languages. Records that were not written in English were excluded. As a result, 40 articles were finally included in the inclusion phase of our review for further and detailed investigation. In the next stage, we collected and extracted attributes from each article relating to authors, year of publication, sources of data, the volume of data, languages of reviews, application domain, technique or algorithm applied, approach category, best algorithms or result, and evaluation metrics, which are considered to be the most significant perspectives for obtaining the major discussion points of systematic review. The information is summarized in a table, and the one we are showing here is a part of it. According to this information, we will conduct analysis and discussion. The next section is sentiment analysis, including the process of sentiment analysis and its applications. In the process of sentiment analysis, the first step is data collection. In this step, authors who study the sentiment analysis in low-resource languages collect primary datasets from a variety of social media platforms, such as Twitter, Facebook, and so on. Other researchers prefer to use the secondary datasets, which are largely acknowledged and have played a significant role in a number of studies. The second step is data pre-processing. In this step, the data samples are firstly cleaned by several procedures, such as converting the uppercase to lowercase, removing unnecessary punctuations, removing hashtags and web links, text correction, and removing stop words. Then the tokenization is conducted by extracting the words from the review text. When using machine learning-based approaches, the tokens need to be encoded to integer values. The third step is analyze and scoring. In this step, researchers employ different methods or models to process the dataset pre-processed in the second step. The fourth step is data visualization and interpretation. In this step, researchers visualize their results in eye-catching charts to gain insights that are easy to understand. Applications of sentiment analysis have covered a wide range of areas and brought a number of benefits to business, governments, and even individual users. First of all, sentiment analysis is a promising tool for governments and authorities to monitor online public application for better risk management and response, especially in the case of emergency or major events like the COVID-19. Additionally, research indicates that social media has become a major source of false information. Therefore, sentiment analysis is a very useful tool in clarifying rumors in a timely manner to appear the community and develop appropriate strategies and take timely actions. For business, sentiment analysis helps determine how customers perceive their products, services, and even the business themselves by analyzing social media data. Then they can improve their image, products, and service accordingly. Thirdly, individuals can also benefit from the techniques of sentiment analysis to receive a personalized service through recommendation systems using sentiment analysis. The next section classifies the publications included in this review into 5 categories according to the methods used for the social media data analysis. As shown in this figure, 17% of publications adopted lexicon-based approaches. 55% used only machine learning approaches. 10% integrated the lexicon-based approaches and machine learning approaches. And 10 of them compared these two types of approaches. And 8% combine the sentiment analysis with other analytic approaches. The lexicon-based approaches were the initial methods employed for sentiment analysis and include two types: the dictionary-based approach and the corpus-based approach. Dictionary-based sentiment classification relies on predefined dictionaries, while corpus-based sentiment analysis is performed based on a statistical analysis of the document's content. Different from the lexicon-based approaches, sentiment analysis based on machine learning approaches train the algorithms with sentimental features in the text to enable them to detect sentiments automatically. The classical machine learning models include KNN, naive Bayes, support vector machine, and so on. The deep learning models include the convolutional neural network, long short-term memory, attention mechanisms, and BERT, and so on. The hybrid method integrates some lexicon-based and machine learning-based approaches. For example, using the lexicon-based approach to select features and machine learning approach to classify. A number of studies also compare the performance of lexicon-based approaches and machine learning approaches. And we have found that several studies try to combine the sentiment analysis with other analytic approaches. For example, social network analysis and statistical analysis models. The next section presents the languages of the social media datasets for the reviewed papers included in this study. Regarding the languages, sentiment analysis has been applied to 11 languages, and the English text is the most researched. Among the 14 papers investigated by this review paper, 55% use primary dataset. The domains of the datasets consist of tourism, health, movie, product, books, and so on. And the most popular primary datasets are IMDb dataset and Amazon product reviews. As shown in this figure, only 18% of publications used datasets with less than 10,000 samples, and 7% of datasets with more than 1 million samples. I would like to talk a little more about section 6, as it is a novelty of this paper. This section discusses the challenges faced by the authors and related to data samples, methods, and evaluation metrics. The first is data-related challenges. It can be further divided into two perspectives, in data collection and data pre-processing. In the data collection, data volume is the first challenge. Although building an adequate training set for sentiment analysis is crucial to improve the accuracy of the classifiers and to avoid overfitting, researchers seem to feel overwhelmed by too much social media data, especially for the studies on sentimental analysis of non-English texts. Scholars often decide to create their own training sets due to the lack of useful datasets and in order to obtain sufficient data samples. It often requires a lot of time and manpower for manual annotation. In addition, for scholars working with primary datasets, the imbalance of data and comments of different lengths can also affect the quality of data. Moreover, in order to use supervised methods, manual comment labeling is often performed after data collection, which may result in bias. This is particularly the case when annotators annotate comments that contain sarcasm or irony. After data collection, pre-processing of the data is often challenging as well due to the data variety. Data from social networking platforms is unstructured and contains noisy information that generally does not provide textual emotional content. Therefore, a range of data pre-processing techniques are required to extract useful information and turn text into a predictable and analyzable form. However, aside from some common pre-processing steps, some studies also exclude non-alphabetic terms, which may lead to the exclusion of emoticons or emojis as well. They are significantly related to the user's sentiments, so removing them from the dataset may influence the performance of the classifiers. The challenges related to methods can be further divided into two issues on the versatility of methods and the efficiency of methods. The versatility of methods refers to the general use of a method. The lexicon-based approaches depend on the presence of predefined words in dictionaries. A model that performs well may not perform well when applied in another domain, because the dictionary used by the model does not contain many words from the other domain. The absence of a comprehensive dictionary makes it difficult to realize the versatility of lexicon-based methods. Sentiment classifiers based on machine learning approaches have the same issue, as they are usually trained using data samples from a specific domain. For the application of sentiment analysis in the real world, aside from the versatility of methods, the efficiency of the methods is another challenge. One reason is that due to the popularity and complex of social media platforms, the user-generated data grows significantly, leading to more manpower, time, and effort to cope with increasing volume and various types of dataset. However, for business and government, monitoring the public sentiment in an effective as well as a timely manner is of great significance. The majority of studies paid attention to the accuracy of the models and ignored the practical aspect of the model, such as execution time. The next challenge is related to the evaluation metrics. After investigation the papers included in this review paper, it can be found that there are a variety of measures that have been used to evaluate the classifiers, including accuracy, F measure, recall, and many other evaluation metrics. The most discussed metric is accuracy, followed by F measure. However, different evaluation metrics may assume different use cases. For example, accuracy assumes that the cost difference between correctly classifying an instance and incorrectly classifying an instance is the same in each category, while the F-score additionally assumes that the true negatives do not add value. Another issue is related to the challenges to the methods just discussed above. While the various sentiment classifiers in existing studies perform great in terms of accuracy, F-score, or other statistical evaluation metrics, few of them were evaluated from the practical perspective. such as execution time, which is crucial to dealing with real-world problems, especially in the areas where data flow is high and answers need to be taken in real time. Our study also provides a reference for researchers to address these issues in future studies. Firstly, for both sentiment analysis tasks on English and non-English texts, it is recommended to use a unified dictionary or dataset containing a variety of subject terms and emoticons or emojis, and should cover as many social media platforms as possible to improve comprehensiveness. In addition, to optimize sentiment classifiers for different domains, scholars need to test and adapt their pre-processing methods to the project. Second, in order to make sentiment analysis more practical, future research should gradually move from applications in a single domain to multi-domain by designing generic sentiment analysis. Third, scholars should pay attention to the use of each evaluation metric when evaluating the performance of their models, as they may assume different use cases. In addition, the efficiency of sentiment analysis models is crucial for dealing with real-world problems. Therefore, future work should evaluate sentiment analysis in a more realistic way that includes the practical use of the methods, such as efficiency, scalability, and extensibility. To sum up, our paper gives insights into the goals of the sentiment analysis tasks, the implementation process, and the ways in which it is utilized in various application domains. It also provides a comparison of different studies and highlights several challenges related to the datasets, text languages, analysis methods, and evaluation metrics. The paper contributes to the research on sentiment analysis and can help interested parties select a suitable methodology for their applications. Thank you for listening to my presentation. If you think our paper is helpful for your study or research, please visit this link to read the full paper for more information and consider citing it, as our paper makes several contributions. Firstly, our paper explores the challenges that researchers may encounter, including issues related to data collection and pre-processing, algorithms, models, and evaluation metrics. It argues that it is not sufficient to consider only the effectiveness of an algorithm, but also its versatility and efficiency. Third, aside from presenting these challenges, we also present potential solutions for references. Lastly, this paper helps scholars to construct appropriate methodologies based on prior research findings. That's all.